Hello guys, welcome to this tutorial. In this tutorial we're going to continue with the boot sector we created in the previous video. We're going to restructure our project a little bit, create a makefile. We're going to read from disk sectors into memory, basically our second stage bootloader, and we'll see how we go from there. So let's restructure our project a little bit. Basically we will remove, we don't need those strings here, we don't need these two, and we'll take the print string routine and put it in its own file here. So now with fasm we can very easily include a file with single quotes, the include command, and just print string.asm. So we don't need also those two. Now let's create our makefile. Our makefile will have, I hope you know a little bit of make. I will try to explain everything as I do it. So we will start with a clean command. Basically we're going to remove everything that ends with binary in our binary folder. We'll create this folder. The next thing we're going to do is assemble our boot sector. So our bin boot.bin, we're going to assemble it using fasm. Boot.asm, we're going to put it in bin boot.bin. We are going to assemble our second stage bootloader. Let me see how I have named that file. Okay, so bin second stage boot.bin, and we're going to use fasm second stage boot.asm bin second stage boot.bin. And now let's name everything as OS for now. So the bin os.bin file, it's going to be dependent on bin boot.bin, on bin second stage boot.bin for now. So let's continue. We will use cat basically, and we're going to put our bin boot.bin and next to it we're going to put the second stage bin second stage boot.bin, and we're going to put all together as bin os.bin. I think everything is right. Yes, everything is right as far as I can see. So let's start reading from disk. First of all, we'll go to our second stage bootloader. I want us to be loaded on address 0x1000 and offset 0x000. So the origin is going to be the offset 0x000. We're going to have 2048 bytes at least. So times 2048 minus dollar minus dollar db0. We're going to include our string file print string.asm. We're going to create a string label, second stage boot str success db series of bytes seg bootloader loaded 0xa, 0xd, 0, and we're going to move into SI register the second stage boot string success, and we're going to call print string. So if we see this string, everything is done correctly. To access that string, we're going to need to set some segment registers. Basically, we need to set move into, we'll do that later. So let's save this file and let's go to our boot.asm and read from disk. First of all, let's create a start label. It's better like that. And let's move everything like this. Okay. So let's read into memory. Read sectors from memory. We're going to use this BIOS interrupt 0x13, and we're going to fill the necessary registers with this information. We need to set 0x02 in the AH register, and we're going to put into AL how many sectors we want to read. The cylinder number is going to be 0, and in the CL we're going to set the disk sector we want to start reading from. Basically the second sector. The first sector contains our first bootloader. This is going to be 02. This is going to be 02 because it's the first hard drive. And then using ESBX, we're going to set where in memory we want to load our second bootloader. It's going to be in 10,000 physical memory. To do it using the segmentation method, it's going to be 1000 into extra segment and 0 into BX. So in order to do that, we're going to use calc to calculate it. So basically we are using hexadecimal now. If we set extra segment into 1000 and we multiply it by 16, basically hexadecimal 10, we have 10,000 hexadecimal. So let's do it. Let's continue. So to read sectors into memory, we're going to move into AH 0x02, and we're going to write comments, of course, BIOS function to read disk sectors. We're going to move into AL how many sectors we want to read. I think it's a safe number to read 4 sectors, so 2048 bytes. How many sectors we want to read. Then into DH we are going to set the head, move DH 0x00 head. In the DL we're going to set the drive, the first drive, so 0, move DL 0x00 drive. Into CH we're going to set the cylinder, move CH 0x002. And into CL we're going to set the disk sector we want to start reading from. So move CL 0x02 sector we want to start reading from. And then we're going to call the interrupt 0x13. Remember, not decimal 13. Okay. Now, if the carry flag is set, it means something went wrong. So we'll print an error message. Let's create read sectors failed string db failed to read disk sectors 0xa 0xd 0, and we're going to set also a label here, read from disk failed, and here we're going to move into si our read sectors failed string. We're going to call print string, and we're going to infinitely jump. So now we're going to say if the carry flag is set, jump to read disk failed. Else we're going to jump to our second bootloader here in this address. In order to do that, memory, we want to place our second bootloader 2. So basically we're going to move into AX 1000, and then we're going to move that in the, as we saw here, in the extra segment. So move yes AX. Then we're going to set the BX register into 0. So we're going to move 0x000 into AX, and then we're going to move the AX into BX register. So that means we will load to 0x1000 0x000, which means physical address 10,000. So now let's go to our second stage bootloader, and if we try to use data from here, for example this address here, we will not be able to do it because the data segment isn't pointing here. So what we're going to do is we are going to put our data segment to point here. So let's move into AX 0x1000. Remember, this is the address. So let's move into the AX 0x1000. Let's move into DS AX. Let's move into, we have already done it just for consistency, into ES, the extra segment, AX. Let's do the same for the stack segment, move SS AX, and let's set an address for the stack segment, for the stack pointer. Let's put the stack pointer to, let's start with 0x8000. Basically it's going to be here. That will give it enough space without disturbing anything. And let's try our code basically. First of all, we'll clear. We're going to create our bin folder, make dir bin. And let's make clean and make. Everything is done correctly. Let's use QEMU, but instead of boot.bin, we're going to put it in bin os.bin. It seems something went wrong. Let's debug a little bit. We have set up, first of all, we need to jump. Yes, of course, I saw what's the issue. Here, if everything goes correctly, we need to jump to 0x1000, 0x0000. Let's see. Make clean, make, and let's use demo. Yep, second bootloader loaded. We have loaded our second stage bootloader into memory. We have read from disk. We have explained a little bit of the segmentation way of reading memory. We have created our make file. Starting from the next tutorial, we are going to read information from the BIOS, from the CPU, the type of CPU, some information from the CPU. We are going to play with some more interrupts. We are going to check some more things from the BIOS. And when we have also created the memory map, we are going to enter into protected mode. So, thank you guys for being here. Please like and subscribe, and I will see you in a few days. Thank you very much.